Okay, good evening everyone. Again, I am sharing this slide. We will discuss about the redox reaction. So the redox reactions, when we will see the redox reaction, then there will have the two reaction. One is the reduction, another is the oxidation, and both reactions will have the will happening simultaneously. This is the fact actually. When the reduction reaction will happen, then oxidation reaction also will be happen simultaneously. So then we will say it is a redox reaction. So one redox reactions mean it is a full cell reaction. Similarly, then the reduction reactions mean it is a one half cell reaction, and oxidation reaction mean it is another half cell reaction. So along with these two half cell reaction, we will get a full cell reaction. This is called um, redox reaction. Now there will have some example and some application of the redox reaction. I will discuss about the application and the some redox reaction which are happening in our environment continuously. Actually, this type of the redox reaction is going on. So then we will have idea that what type of the application and what type of the effects this type of the redox reactions has actually. So to know this type of application, first I will discuss about the burning of fossil fuel. What is that? This is the burning of fossil fuels. So the burning of the fossil fuels, the fuels means that is containing the carbon. This is the fact. Everything, wood, like the wood. So the wood is containing the carbon. So when in presence of oxygen, this type of the fossil will be burned, then what will happen? The carbon dioxide will be forming and simultaneously we will get the energy. So this energy actually required. This energy is necessary for our lifestyle. That's why we burn this type of the fossil fuel. But point is that this fossil fuel containing the carbon. So in presence of carbon, this in presence of oxygen, this carbon is oxidized and it is forming carbon dioxide and the energy, and this energy is required. So here the carbon is oxidized. So this is one example of oxidation reaction. This is one example of oxidation reaction. We will know later that how we will know what is the oxidation reaction and how we will know that it is a oxidation reaction and it is a reduction reaction. That I will come in later. Second example I will show you here, the corrosion of metal. This is also example of a oxidation reaction. So what is the corrosion of metal? Basically it is also oxidized form of the metal. Suppose this is the metal. So this metal has oxidation state 0, but in presence of oxygen it will oxidized. It will oxidized like the Fe, iron. We know this is the iron. So in presence of oxygen it will oxidized like Fe2O3, like Fe3O4. This type of the oxidized form, this iron can exist in presence of oxygen. So here these are the oxidation reaction which are happening in our nature continuously. So these are the oxidized form of this metal. Like that we can write another oxidized form of the metal like rhenium, like TiO2, like zinc oxide. So these are the oxidized form of the metal which could be formed in presence of oxygen. Here the metal is oxidized in presence of oxygen. So in presence of oxygen, metal is oxidized and it could be formed like the Fe. Fe is oxidizing in presence of oxygen and it is forming the Fe2O3, Fe3O4. So these are the two oxidation reactions which are happening in our nature continuously. Another example I will show you like photosynthesis reaction. Photosynthesis. Carbon dioxide in presence of water, it forms C6H12O6 plus 3O2. So this is a photochemical reaction. So in this photochemical reaction, this carbon dioxide goes to reduction reaction and the water goes to oxidation reaction. So basically here two reaction is happening. One is the reduction, another is the oxidation. So and these two reaction is happening simultaneously. So we can say it is a redox reaction. It is a redox reaction which is happening in our lifestyle in the nature as a photochemical reaction. So these are the application and these are the example of the redox reaction which are happening in our nature simultaneously. Now the question is how we will know which is oxidation reaction and which is the reduction reaction. This is the fundamental thing. So there are the some idea. One idea I will show you, classical idea. There are some classical ideas to know about the oxidation reaction, about the reduction reaction. One by one I will discuss here. First I will discuss about the oxidation reaction. When we will see addition of oxygen in a chemical reaction, then we can say it is a oxidation reaction. Like there are some example I will show you here. Magnesium in presence of oxygen, it will be oxidized to magnesium oxide. Similarly, sulfur in presence of oxygen, it will oxidize to SO2. So here magnesium is free. Magnesium has oxidation state 0, but in presence of oxygen, it is forming magnesium oxide. It goes to +2 oxidation state. So here oxygen is adding to magnesium. So this is a one type of the oxidation reaction. Similarly here oxygen is adding to sulfur. So this is a oxidation reaction. Second criteria is there removal of hydrogen from substance. When we will see in a chemical reaction there is hydrogen is removing from a substance, then we can say it is a oxidation reaction. There is some example. Now what is happening in this reaction? In this reaction, in presence of oxygen, H2S is oxidized and simultaneously if you see this hydrogen is removing from H2S and it is forming sulfur. So here in this chemical reaction the substance is H2S. So from this substance hydrogen is removing. So it is a oxidation reaction. Another example I will show you. So there is third criteria is addition of electronegative element. This is a very important thing, importance criteria, the addition of electronegative elements. So we know that in our periodic table, basically this type of the elements are electronegative and these elements are the electropositive. Okay, so now if you see the example, the magnesium in presence of fluorine gas, it is forming MgF2. So we know that fluorine is electronegative, here is there. So fluorine is electronegative and magnesium is in zero oxidation state. Here the fluorine is adding to magnesium and forming MgF2. Here magnesium oxidation state is +2. So electronegative element fluorine is adding to this substance. So this is one type of the oxidation reaction. Another example, magnesium in presence of chlorine, it is forming MgCl2. Here also the chlorine is electronegative element which is adding to magnesium and forming MgCl2. It has a plus oxidation state, magnesium has a zero oxidation state. There is four criteria. Four idea is that removal of electropositive element. That means this type of these elements will be removed from the substance in this type of chemical reaction. So what will example there? This is the example. So in this example, if we see in this metal complex, so these are the metal complex. So in this metal complex, 4 potassium element is there. But after reaction, we are getting a product here 3 potassium. So 1 potassium, and potassium we know it is a electropositive element. It is exist as potassium plus ion cation. So it is a electropositive element. So this electropositive element is removing from this substance and forming the KOH and forming this type of the metal complex. So here this electropositive element is removing. So it is also a oxidation reaction. So these are the classical, these four are the classical idea to know about the oxidation reaction. So I will write for the oxidation reaction what are the actually classical idea we have taught here. Oxidation reaction, for oxidation reaction, first I have seen here addition of oxygen. Second is removal of hydrogen. Third is addition of electronegative element. Fourth is removal of electropositive element. Now, so what are the classical idea about the reduction reaction? So for the reduction reaction, this criteria will be opposite for the reduction reaction. So to know which are the oxidation reaction, which are the oxidation reaction and which are the reduction reaction, you just remember for these four criteria for the oxidation reaction. Automatically for the reduction reaction, this will be the opposite. Like it will be the removal of oxygen, it will be addition of hydrogen, it will be just opposite, removal of electronegative element, and the addition of electropositive element. I will show you some example of the reduction reaction where this classical idea are happening. First is that removal of oxygen for the reduction reaction. So the example is in presence of heat, HgO will form Hg plus oxygen. So in this chemical reaction, oxygen is removing from this substrate. So it is a example of reduction reaction. Similarly, for the addition of hydrogen, it is a alkene. In presence of hydrogen, it will form the ethane. So this example actually we can say this type of the reaction, the hydrogenation reaction actually, hydrogenation reaction, hydrogenation of alkene. Third is removal of electronegative element. So this metal salt, in this metal salt, chlorine is electronegative element. So it is removing from this metal salt and it is forming the FeCl2 and HCl. So one electronegative element is removing from the FeCl3. So it is one type of the reduction reaction. Fourth example, addition of electropositive elements. What will be example? So here this is the electropositive element. Okay, so this is the electropositive element. So after reaction, here is one mercury, here is two mercury. So one electropositive element is adding. So this is one type of reduction reaction where the electropositive element is adding to the substance. Simultaneously, so this is the reduction reaction, another is the oxidation reaction. So this is the reduction reaction and this is the oxidation reaction. So from the what criteria we can say it is a oxidation reaction, because if you see that this is the chlorine, it is a electronegative element which is adding in this reaction medium and with this SnCl2. So that's why we can say it is a redox reaction where reduction reaction is happening and also oxidation reaction is also happening. So these are the classical idea, basically where we can say it is a oxidation reaction and it is a reduction reaction. So just remember for the four criteria for oxidation reaction, so it will be easy to remember for the reduction reaction also. Otherwise it will be the mixed up. So I will suggest the student for the oxidation reaction, just remember for the oxidation reaction these are the four criteria. These are the classical four criteria to know this is the oxidation reaction and this is the reduction reaction. But how we will know the oxidation reaction and reduction reaction in terms of the electron? Basically, redox reaction containing the transfer of electron, actually the theory of the transfer of electron, where in a reaction electron will be removing, in another reaction electron will be adding. So to know this type of theory, but to know about this electron transfer term, electron transfer theory for the redox reaction, before that I will show you some ionization form of the metal complex, how we can write the ionization form of the metal salt as a cation, as a anion. Suppose there is FeCl2, this is a metal salt. How I will write this as a cation form, and as an anion form, because we know that NaCl it is formed like Na plus Cl minus. So it is easy. Na plus Cl minus. KCl. This is a potassium plus Cl minus. But there are some difficulty to know how many cation, how many anion is there, and what will be the positive charge, and what will be the anionic charge of this anion. So to know this rule, but to know the right, I will show you here a shortcut. This is the very important thing to know the electron transfer, how the electron is transferring in a redox reaction, for a oxidation and for the reduction reaction. This is a very important thing. Like I have a metal salt MXNY. So M is cation, N is anion, like NaCl. M is sodium and N is Cl. And X and Y, these are the one, like NaCl plus 1 plus 1. So here also 1, here also X and Y. So when we will write this metal salt as a cation and anion forms, as a ionization form, it will be have like that: X M Y plus and Y N X minus. So this X will be come in front of the M, and this Y will be as a charge, like that. For the N, X will be like the charge, and Y will come in front of N. So it will be the ionization form of this metal complex MXNY. I will show you some example here, like N2S. So here the sodium and the sulfur. We know the sodium is cation and sulfur will be the anion. And sodium, this is the 2. So X equal to here 2 and equal to 1. So Y equal to will be 1. So how I will write that? It will be the 2N. 2 is coming in front of sodium, and 1 will be as a charge. So Na plus, like it will be the sulfur, and 2 minus. So another example I will show you here. This is the N2O. So it will be the 2Na plus and O2 minus, because oxygen, this will be the 1, because oxygen gives the 2 minus charge. So that's why oxygen 2 minus, and MgCl2. So it will be the magnesium plus 2. So there is 1. So magnesium plus 2. So 2 is coming as a charge. Okay. And 2 will come in front of the Cl. So 2 Cl. And there is 1. So charge will be minus 1. Like I will show you NiCl2. So it will be the nickel plus 2, 2 Cl minus. So like that, we can ionize this type of the metal salt as a cation, as an ion, because if we know the ionization form as a cation, as an ion of a metal complex, easily we can write that they are the oxidation state actually. So now I will show you some tricks to know, to be easy, how there will be loss of electron and there will be gain of electron. Basically, we know that when we will see the charge is plus, like Na plus, that means there is loss of electron. There is loss of electron. When the charge is negative, that means it is a gain of electron. Suppose there is plus 2 charge, so loss of 2 electrons. Suppose there is minus 2. So this is the gain of 2 electron. So these are the basic idea, these are the basic term we have to know before to know the redox reaction terms of the electron transfer. Okay, because electron transfer, that's mean there will be loss of electron, there will be the gain of electron. So when it will be the loss of electron, that means the positive charge will be created on the metal. When it will gain of electron, then the negative charge will create on the metal. So these tricks, and this is the ionization form of the metal complex, how we can write easily, and these are the basic trick we have to know about before that a redox reaction in terms of the electron transfer. So here after that I will discuss some MCQ question to know the oxidation state. Actually, basically this MCQ question based on the oxidation state. I will not say the answer, but I will show you some tricks, some example to know how to do the oxidation state. Okay, so first the MCQ is, which of the following process take place in the oxidation process? So I have discussed already. There are the 4 criteria. If you just see the which criteria is matching with that, so you can get the answer from that for that MCQ question. The another question is the loss of the electron. That I will teach you in the next class. You will be able to do this type of MCQ question. Now, what will be the oxidation number of the 3 element, like the Fe, iron? It is a free, like the magnesium. It is a free. It is free means it is not attached with another element. Suppose there is FeCl2. It is not a free. It is attached to chlorine, like MgCl2. So magnesium is not free. Magnesium is attached with 2 chlorine. When any element will be free, like the Fe and the magnesium, then there will have the oxidation state 0. So it will be answer will be the A. So another question is oxidation state number. For oxidation state, how we can write, how we can derive the oxidation state. So to know the oxidation state, I will show you one example like HNO3. So HNO3. Here we have to know the oxidation state of nitrogen. So nitrogen, I have to know the oxidation state of nitrogen. So I have to know. So I will write the oxidation state of nitrogen is X. We know the hydrogen gives +1 charge and oxygen gives -2 charge. But there is a 3 oxygen. So it will give into 3. So to know the oxidation state, there is rule that sum of all oxidation state, all the charge, it will be positive, it will be negative, whatever, the sum of the charge will be 0. So what will be the X? It will be +1 plus X minus 6 equal to 0. So X equal X minus 5 equal to 0. So X equal to +5. So nitrogen has the +5 oxidation state in HNO3. So in this way, we have to calculate the oxidation number or the oxidation state of any element in a substance. Like here NH, calcium hydride, lithium hydride. So here the question is oxidation number of hydrogen. We know the metal, and another thing I will write here. Generally metal gives the positive charge. Metals gives the positive charge. So here the sodium is metal, calcium is metal, lithium also metal. So sodium, calcium, lithium, they will give plus positive charge. I will not say the what will be the charge, but I am saying that it will be the positive charge. So to know the positive charge, you have to calculate what will be the oxidation state of hydrogen for that sodium hydride, calcium hydride, and the lithium hydride. So this is the another question. The oxidation number of the chromium in the potassium dichromate. So what will be the chemical structure of the potassium dichromate? It will be the K2Cr2O7. So I have to calculate the chromium. So it will be the chromium. So chromium is a transition metal. It is a transition metal. So it is a metal. So generally it will give positive charge. So to keep this mind and calculate the oxidation state of the chromium, because we know the potassium is metal, it will give positive charge. Chromium, we don't know, that I have to calculate. And the oxygen, we know the every oxygen, but one oxygen gives the -2 oxidation state. So what will be the oxidation number for the chromium that we have to calculate? Another question is like oxidation number of the cobalt. This is a very important question because this is a metal complex. These are the metal complex. Okay. So to know the oxidation state of the cobalt, first of all, we have to know what elements are attached with this cobalt, because here the cobalt is not free. When the cobalt will be the free, then oxidation state will be 0. That is no problem. But here the potassium is attached, carbon monoxide also is attached. So what will be the oxidation state of the cobalt, that we have to calculate. So before calculation, we have to write this metal complex as a cation and anion form. We know that potassium is a cation, so it will be the K plus, because this also 1, this also 1, so it will be the positive potassium ion, and another total form will be the negative. So I have written here potassium plus and cobalt CuR whole form minus as a cation form, as an anion form. Now we know it is a potassium, so it will have the positive charge. We have to calculate the oxidation state of the cobalt. So I have written the X. But what about the CO? Because there is carbon, there is oxygen, but oxygen gives the negative charge. So what will be the carbon? So basically, in organometallic chemistry or coordination chemistry, we can say that the CO is a ligand, is binding to this cobalt as a ligand, because this type of the metal complex, there will have two types of ligand. One is neutral ligand, another anionic ligand. Okay, we can see two type of the ligand. One is the neutral ligand, another is the anionic ligand. Here the CO is neutral ligand, but then for the neutral ligand, it will give the charge 0, but for the anionic ligand, it gives the charge negative. Like we can say the Cl minus, it is an anionic ligand. Bromine minus, it is an anionic ligand. So we have to know which type of the ligand is attached to the metal complex. It could be neutral, it could be anionic. So here the CO is neutral, so it will give the 0. So now it will be easy. Now it is easy to calculate the oxidation number of the X. So what will be the oxidation state? because we know the potassium +1, it will be the +1. For the cobalt, we do not know, so that will be the +X. Now the CO oxidation, yeah, it is a neutral ligand, so it will give 0. So it will be 0 into 4, because 4 CO is there, so it will be the 0. So this is the criteria, but this is the equation for to know the oxidation state. So now X equal to -1. But I have said that generally metal will have the positive charge, but here the cobalt has -1 charge. These are the some example in organometallic chemistry is there. The oxidation state of metal is negative. There are some example also is there. We can see, but generally oxidation state of metal is positive charge. It will be the plus charged. Now here the oxidation state of the carbon, we have to calculate the carbon. So first of all we have to know which element is there. Hydrogen is there, chlorine is there, carbon is there. So carbon I have to calculate, so X. We know that hydrogen gives the positive 1 charge, so there is 2, we have to know, and the Cl gives the anionic ligand, I have said here, so it will give the -1 charge. So just calculate it, it will gives the exact but correct oxidation number of the, for that carbon. Now another question is oxidation state of the osmium. So here also osmium is metal, and osmium is attached to oxygen. So osmium is not free. So osmium has no zero oxidation state. It will have something positive, something negative, but oxygen gives the negative charge, So obviously, sorry, oxygen will give the negative charge. So obviously, osmium will give the positive charge, because in a metal salt, I have seen, I have shown that in a metal salt there will be cation, there will be the anion. So this is the anion. So what will be the cation? Osmium. So and we know that oxygen gives the -2 charge. So there is the 4 oxygen. Just calculate it. It will give the answer. Now the another question is very important. Which of the following transition metal has the zero oxidation state? So we will have the in mind that it is giving the zero oxidation state. That means the metal is free. That means the metal is free, because I have shown here the metal is free. That means it will give the zero oxidation state. But there are the some example. There are the some example in organometallic chemistry, because I have already said that there are the two ligands. One is the neutral, another is the anionic. So for neutral, it gives the zero oxidation state, and the anionic, it gives the negative. So metal are not free in this 4 option. So what will be the other chance? The other chance is neutral ligand. So then we have to see that which metal is oriented to the neutral ligand. So here you see that this is the chromium. Chromium is metal, but it is attached to oxygen. But oxygen is anionic. This is the hydrogen, NH2 NH2. So there is no metal. These are the nitrogen element. So the transition metal means scandium, titanium, vanadium, 3D, 4D, 5D, this element. So there is no transition metal. So it will no answer. Another is the option is B, nitrogen, oxygen, chlorine, oxygen. So there is also no transition metal. So another option is A. It will be the answer, because it will be not answer, it will be not, it will be not. But now question is how? Because we know that CO gives the 0, because CO is a neutral ligand. CO, it is a neutral ligand, so it gives the 0 oxidation state. So what will be the oxidation state for the iron? Because X plus 5 into 0 equal to 0, so X equal to 0. So iron will have 0 oxidation state. Iron will have the 0 oxidation state. So another criteria also is there. When the metal will have the 0 oxidation state, the metal will be the free and metal will attach to the neutral ligand. So these are the 10 questions here I have shown, and I have also written some tricks to know the oxidation state, how to calculate. There are the 5 or 6 questions, the remaining you people just do it, and if you have any problem you can ask me. In the next class I will discuss. Okay, thank you.